Okay, we're going to look at a couple of homework problems from Chapter 2, specifically 222 and 231. What we're dealing with is basically three forces acting on a point right here. There we go. And we're going to just go through, and the first part is right here. It asks for basically the x and y components of each one, and then the second part is you come up with the resultant, which is you just add them up. So let's first do the x and y components. Okay, so we'll start with this force right here. So you have 29 pounds going off in this direction, and you're given this information. So you could go through and you can figure out this theta, right? You could say, okay, well, tangent of theta is opposite, which is what, 80 over 84, and therefore theta is equal to, get out the calculator, 80 divided by 84. The arctangent is 43 point, oh, that was not what I expected. 43.6028, some number. So just some distance, right? Okay. So, and then you can say that therefore the x component of that is going to be 29 times in the x direction, so it's going to be this portion right here, so it's going to be 29 times cosine of theta, and the other one's 29 sine theta. And that'll work. I just don't want to do it that way because it's not the easy way to do it. Instead, I'm going to show you kind of a little trick that is going to be used throughout this semester on this very thing. So I'm going to figure out this triangle. I'm going to figure out this hypotenuse right here. So it's 84. So 84 squared plus 80 squared, square root of that. And that works out to be, surprisingly, I wrote this down in advance, 116. So this length is 116. Okay, why do I care about that? Well, okay, if I'm claiming that the x component of this, that was weird. The x component is, I'm going to call it this, I'm going to say 29 in the x direction is equal to 29 times cosine of theta, right? Well, what is cosine of theta? Theta is 43.60, so you could go through and figure it out. But you could also say the cosine is the adjacent over the hypotenuse. Well, the adjacent, that is equal to 29 times 84 over 116. That is what cosine of theta is. So so that works out to be 29 times 84 over 116 is equal to 21. So the x component of that is 21. And if you take the cosine of that, it's the same thing. You get the same answer. To me, it's just easier to do it like this. Okay, so here I'm gonna do a little chart right here. I'm gonna say 29 in the x is equal to, therefore, 29 times 84 over 116, which is 21. 29 in the y is 29. And this is going to be sine theta, but it's the opposite, 80 over 116, which works out to be 20. Now 50 in the x is going to be what? Well, here we're looking at this triangle right here. So here, if you look at 28 squared plus 96 squared, this works out to be 100, which is really convenient. So 50 in the x is equal to 50 times. Now this is where why I wanted to do this problem. It just depends on who you define it. If I define this as, we'll call it phi, then the x component is going to be this angle, so it's going to be 50 cosine theta, or phi, but it's going to have a negative value, right? Because the x component is clearly going that direction. So how come sometimes it's sine, sometimes it's cosine? It's just a matter of using your head. If you always define things from this axis in this direction, so if you define that for that angle, then x is always going to be such and such cosine theta, and y is always going to be such and such sine theta. But quite frankly, it's unnecessarily hard when they give you these numbers, because really you can just look at this. You can say 50 is going to be, the x component of it is going to be 28 over 100, and it's going to be negative. How do you know it's negative? Because you can just look at the picture. It's going negative, right? It's in the negative x direction, so this works out to be minus 14, So 50 in the y is equal to 50 times 96 over 100. That's a 100, sorry about the writing. And that's equal to 48. And that is positive as compared to the other one is negative. How do you know it's positive? Because it's pointing up. That's what it is. Okay, and then the last one, if you look at the square root of 90 squared plus 48 squared, it's equal to 102. So therefore, 51 in the x direction is 51. The x component is going to be this one over the hypotenuse. So you're looking at, I've made a little bit of mess here, it's going to be 48 over 102. So that's equal to 24. And 51 in the y direction is going to be 51 times 90 over 102, which is equal to 45. And again, this one is going to be in the negative direction because it's the down component of that. So that's the key to doing these things, is when you're doing when they give you these distances, you can go through and you can calculate theta, and you could do this bit where you're taking the arctangent of each angle, or the sine or arcsine or cosine. But you don't need to, because you're just going to turn around and take the sine and cosine of it, and the sine and cosine is always just the opposite or the adjacent over the hypotenuse. And so it just makes it a lot easier, and quite frankly, this book, I don't know how they do it. They come up with all sorts of different ways to get nice even numbers. Again, this is 102, 100 there, and 116 there. They'd come up with all sorts of ways to do nice even numbers. And there you go. That is 22. We're done with that. Now, let's take a second and look at 31. So determine the resultant of the three forces. Well, how do you do that? Well, this is why you do things in the x and y, because simply you just add them up. It's just that simple. And so if you're trying to find the resultant in x, I'm going to call it r, and x is just equal to the sum of the x components. And that's what that says, believe it or not. Okay, so what do we have? We have 21 minus 14 and 24. So you just go, so it's just 21 minus 14 and 24 added up, and so it's equal to r in the x is equal to 31, and r in the y is equal to the same deal, 20 plus 48 minus 45. 20, 48, 45, so we're looking at plus 23. This is plus. And so the more kind of correct way, if you will, to put this would be to say that r is equal to, the r vector is equal to 31 in the I direction plus 23 in the J direction. Now in the book, a bunch of times they'll turn around and put this in magnitude and angle, which I don't love. And quite frankly, I'll never ask you that of the test, because I find that kind of irritating, because this is the more useful thing. But just for giggles, let's go ahead and write that down. So the magnitude of r is square root of 31 squared plus 23 squared, right? Which is equal to what? 31 squared and that squared, add them together, square root. So you're looking at 38.6, and the angle is a tangent inverse of, so we're looking at boom, boom. So it's off in this direction somewhere, and so the opposite, so 23 over 31, 3 over 31, which is 23, 31 divided arctangent, 36.6 degrees. I think this is how the book gives it to you. Please don't do that. I don't care about that. This is the right answer, because you're going to turn around and use this later. You're going to do moments, you're going to do other things where you need that information. This is not a helpful form. Although it's true, it's not a particularly helpful form. This is a very helpful form. And so that is what we're looking for. So you can just add them all up. Again, that is the whole point of why we do these things in x and y's, because you can quickly add them up and make life easy. There you go.